Structural isomers. Objectives: define isomer, describe the types of structural isomers, draw structural isomers. What are isomers? An isomer of a molecule is a molecule with the same molecular formula but a different structural formula, resulting in different properties. In this example, both compounds have 5 carbon and 12 hydrogen. However, one is a straight chain and one have a carbon on the second carbon in the longest chain. What are the types of structural isomers? The first type, chain isomers. The position of the carbon atoms in the molecule can be rearranged to give a branched carbon chain from the parent chain. Here we have C5H12 as pentane in a straight chain, and we have 2-methylbutane when it's a branched chain. The second type of structural isomers are position isomers, where the position of the functional group changes. For example, we have 1-butene with a double bond present between the first and second carbon, and 2-butene with a double bond present between the second and third carbons. Finally, the third type of structural isomers, functional group isomers. Here, the atoms are rearranged to give a different functional group. In the first example, we have a double bond O at the beginning of the molecule, which is an aldehyde. It's called propanol. And in the second example, the double bond O is found on the second carbon, which is a ketone. It's called propanone. How can we draw chain isomers of alkanes with 1, 2, 3, or 4 carbon atoms? When we have one carbon atom, methane, we need to remove one of the terminal carbon and place it in a non-terminal position. However, there's only one carbon, so there are no isomers when there's one carbon. When we have 2 carbon, it is the same. When we have 3 carbons, we can remove one of the terminal carbon and place it in the middle. However, it will still be propane. It is still a 3-carbon chain. In 4 carbons, we have one long chain, which is called butane. When we remove a terminal carbon and place it on the second carbon, it forms a branch chain alkane. It is called 2-methylpropane. Since there's only one place for the methyl to be attached, a number is not associated with the name. Alkanes with 3 or less carbons have no isomers, while 4 carbon has 2 isomers. How can we draw chain isomers of an alkane with 5 carbon atoms? First, we remove one of the terminal carbon and place it in a non-terminal position. This is our terminal carbon. We'll be moving it to the second carbon. It's called 2-methylbutane. Now, if we were to take that terminal carbon and place it on the third carbon, it would form the exact same molecule when we're numbering it from the right to left direction. It will still be 2-methylbutane. Now we take another terminal carbon that's at the end of the long chain and we move it to the second carbon. Here it forms 2,2-dimethylpropane, another isomer. In total, when we have 5 carbons, there are 3 isomers. The more carbon atoms present, the greater the number of isomers. How can we draw position isomers? In position isomers, the position of the functional group changes. For example, an isomer of 1-butanol on alcohol could be 2-butanol, where the OH is no longer on the first carbon, it is now on the second carbon. How can we draw functional group isomers? In a functional group isomer, the atoms rearrange to form different functional groups. For example, the organic acid C4H9COOH can be rearranged to form an ester CH3COOC3H7. The following functional groups are isomers of each other: alcohol and ether, aldehyde and ketone, organic acid and ester. Additionally, alkenes and cycloalkanes are also functional groups of each other. Practice question 1. Which compound is an isomer of CH3CH2OH? In this question, we first need to count all the carbon and hydrogen in our isomer. Here we have 2 carbons, 6 hydrogen, and 1 oxygen. Then we count all the number of carbons and hydrogen in our answer choices, and finally, choice 3 matches because isomers have the same molecular formulas.